Hello busy people, welcome back to my channel Code for you. Today I am going to solve daily Leetcode challenge, delete nodes from linked list present in array. The question states that you are given an array of integers nums and the head of the linked list. Return the head of the modified linked list after removing all nodes from the linked list that have a value that exists in nums. Now we are also provided with some examples and also with some constraints. Let us talk about constraints. The nums.length array value should lies between 1 to 10 power 5 and nums value also lies between 1 to 10 power 5. All elements in nums are unique. The number of nodes in the given list is in the range of 1 to 10 power 5 and the node value should lies between 1 to 10 power 5, and they have also clearly stated that the input is generated such that there is at least one node in the linked list that has a value not present in nums. Let us see the same question with examples. So first example, they have given two input values, one is a nums array and the second one is a linked list. There may contain duplicate values in nums array, so we use set data structure to store this nums array so that if there are present any duplicate values they are removed. And if we come to linked list, basically a linked list nodes are built using two elements. First element is data element and second element is next element. Data element contains the data values and next element contains the address of the data value. So with these nodes we can create a linked list. In the same way I have created a linked list which is connected one another using their addresses. So to traverse this linked list I have used head node which contains the address of the first node, and first node contains address of second node, and second node contains address of third node, and third node contains fourth, and fourth contains fifth. Same. In this way we can traverse from head node to last node. So to keep track of the modified head value, I am created a duplicate linked list which is dummy, and also I have first initialized it with the first node of the original linked list. So to traverse through the original linked list, I am using a temp node to traverse through the original linked list. So first I will check if the first node is empty or it contains something. So if it contains something it moves into the while loop, and second it will check if the node value is present in the set data structure. If it is present in the set data structure, we'll remove that node. Here the one is present in set data structure, so we'll remove this node and will store next node address into the modified head value, and in same we'll check for the second node if second node is present in the set data structure or not. If it is present in the set data structure, we'll remove this node and will store next node address into our modified head value, and we'll check for the same, it is also present in our set data structure, so we'll remove this node, and finally we'll store fourth node address into our modified head value, and 4 and 5 not present in our modified set data structure, so we'll finally return our modified head value as dummy.next, so that dummy.next will traverse through the linked list and prints node 4 and node 5. For better understanding, we'll see another example. In this example, nums array has only one element, so we'll store it in our set data structure, and we construct the linked list which contains 1 2 1 2 1 2 as the nodes, and also as our next step we'll create a dummy linked list which is initialized with 0 data and head as the address value. Head contains the address value of the first node. So same process, we'll repeat the same process which we have done for the example one. First we'll check if the first node is contains something or empty. If it contains something, then we'll check it is present in set data structure or not. It is present in set data structure, so we'll remove that node and we'll place next node address into our modified head value. We'll check for this node also same, if it contains in set data structure or not. If it is not contains in our set data structure, then we'll move to the next node. Now our modified head value is changes from here to here. So now we'll check if our third element is present. Yes, it is present in our set data structure, so we'll remove it and we'll store our fourth node address in here. I will remove it and I will store 4000 here. We'll check the same condition here, if 2 is present in our set data structure or not. If it is not present, then we'll move to the next node. Next node, it is contained in our set data structure, so we'll remove this node and we'll store next node address in this node, this 6000, and finally we'll return the modified head value as dummy.next, so that we can traverse from dummy.next to here and here and here. We'll print modified list as 2 2 and 2. In this manner we can solve this whole question. Now we'll code the same in Java. Initially we have to store our nums array in set data structure. For that I'll create a set data structure hash set, and I will store every element of nums array to set data structure, so that if there are any duplicates they will be removed. And in next step I will create a dummy linked list which is list node dummy new list node, and first I will initialize it with 0 as data value and head as address value. And to traverse through the original linked list, I will make use of temp node to do that. First I will check if that linked list is empty or not, or if the address value is null or not. So temp.next not equals to null, then it will go and check if that node value is present in set data structure or not. temp.next.val. If it is present in set data structure, then we'll remove that node by assigning next node address to the modified head value, else I'll move to next node. Temp is equals to temp dot next, and finally I'll return modified head node as dummy dot next. Let's run this code. Small mistake. Okay, we'll run this one. Yes, successful. Finally we'll try to submit it. Oh, 87%.